Okay, yep.
I think for the PSAT, could you focus on this section on upcoming classes?
Problem solving in data analysis? Yes, sure.
That was my lowest scoring section of the thing.
This is your PSAT score?
Yeah, out of 15 to 20.
15, 20. That's pretty good. That gives me a lot of confidence. Cool. So, good job, Praneeth. So Praneeth, come over here. I want you to be my star today. So, see, this is my takeaway, okay? Here is Praneeth. If you guys have not met him before, he is with me. He's the one who's been tolerating me for quite some time. And we have come here so that you come in the video actually. So he did his pre-SAT and he got close to 1400 out of 1520, and he very well knows what are the areas where he has to focus on. So he was asking me, sir, can you focus on these things in future? And that's what I want each one of you to do. Thank you so much, Praneeth. So all of us, right? I mean, excluding me, everybody has to give test, and test is not something scary, right? I always want you guys to kind of take test without any fear and figure out what are the areas where you have an opportunity for doing better, okay? And that is what will make me relevant, that is what will make you more successful. So whether you're getting 1000, whether you're getting 1550, doesn't matter. It's always a relative score. So when you're getting 1000, you have to target for getting to 1100, 1200, 1300, 1400. And then how you can do it is only by not stressing out, but by finding out areas where you can do better, okay? So take it like a race. I don't believe in rat race for that matter. It's all about concept, but yeah, if we know where we have opportunity for doing better, that is what will make us do better in the coming exams, okay? So there's nothing that I'm bragging about. I'm just telling you guys that this we have to learn things, learn concepts in a more sportive way, okay? Do it like a sport, okay? I did take test this time. This is where I did well. This is where I have opportunity for doing better. Work on it. Give that feedback to your teacher. Say, okay, sir, these are the areas where I think either you have not done a good job or I have an opportunity for doing better. Any which way is okay. All right. That was the speech to do the jump start. So let's do a quick roll call. We have Dev, Jana, Khushi, Ritika, Sahit, Samriddhi, Saranya, Viswa, Vivan and Yasmita. And here in the classroom we have Arush and Praneeth. I saw Sahit in between. Where did Sahit go? Sahit is there. Yep, Sahit is there. And then we have Vishal as well. Alright, so shall we get started? There's no reason to say no, right? We are all here for a class. Let's get started. Alright, so far we have been, in last couple of classes, if you recall, we have been talking about advanced geometry, where we talked about its surface area, volume of different shapes, simple objects, compound objects, whatnot. And then we try to put as much creativity as possible around it to visualize these objects and then determine the surface area and volume. Then we moved on to trigonometry. That is where we again went back to the concept of unit circle, looked at different ways to find out the relationship between sine, cosine and tangent, and we kind of re-looked at SOHCAHTOA. So Praneeth, what I would do is, you showed me that thing, just take a printout of the key areas that we have to focus on and send it to me on WhatsApp, okay, so that even if I'm old, I don't forget, okay? Alright. So we will continue with our journey with trigonometry and the things that we are going to cover in the class today, most likely, most of it, unless something spills over to next class. We are primarily going to deal with trigonometric ratios, sine and cosine, complementary angles, and then we'll look at some practical problems and see how we are all reacting to it as a group. Yeah? So, all about practice. There is one thing that you cannot do away with, that is practice, because math is all about practice. Yeah? Concept and practice. So let's first look at touch upon some of the basics of trigonometric ratios and then the concepts around complementary angles and the relationships, and then we'll straight away jump onto some of the problems that we want to deal with. Is that okay? Saranya, Ritika, Yasmita, Dave, Jenna, everybody, Kushi. So, and my most recent victim is Kushi. Yeah, Kushi, do you feel bad about it? All the kids have been getting bothered by me for some time. You are the latest, what you call, victim of this whole thing that we do it together. Yeah. So if I call out your name, Kushi, a couple of times, don't worry about it. Okay. It's just an attempt by the teacher to make sure that everybody is on the same page. Yeah. So let's quickly look at what do you mean by trig ratios. Anybody in the class who is struggling to recall what do you mean by trig ratios? No? Pranay is saying, see, why are you bothering me about trig ratio which you have done so many times already? Anybody in the class? Vivan, do you remember? Do you know what do you mean by trig ratios?
No, sir.
SOHCAHTOA is on your tip of the tongue. Yep. Okay. So let's quickly glance through it once, and then we will come back to what do we mean by the rule of complementary angles. Okay. So even if some of you are getting a little worried, don't worry. This is something that has to stay with us. If you guys know that Gorilla Glue is the best glue, get it glued with you for next 10-15 years. Okay. So SOHCAHTOA, this just gives you the basic way to relate sine, cosine and tan. And if now I remember one thing, in the last class I was saying that we talked about SOHCAHTOA and then we looked at unit circle also a little bit, and I was asking why do we need to worry about unit circle. And some of you were, okay, let me not switch much. Let's go step by step. So this one says that if you have a right angle triangle and the SOHCAHTOA gives you the relationship or the definition of all the trig functions. And when I say trig functions, I'm essentially talking about sine, cosine, and cosine we also call cos, so and tan. So if you have a right angle triangle with A and B making the 90-degree angle, side A and B making 90-degree angle, this C is nothing but your hypotenuse, which is opposite to the 90-degree angle. So sine theta based on this SOHCAHTOA, S stands for sine, opposite side divided by hypotenuse. So here, if you take this as your angle theta, so sine of this theta will be equal to opposite side divided by hypotenuse, opposite by hypotenuse. So this is A by C. And cos of theta, CAH, ka. Cos of theta is adjacent side by hypotenuse. So here, this is your theta, adjacent side is this one, B over hypotenuse. So B by C. And tan of theta, TOA, tan of theta is opposite side by adjacent side. So opposite side to this angle is A by adjacent side B. Or other relationship that you can see from here is tan of theta is equal to sine theta by cos theta. Sine of theta is A by C divided by cos of theta, which is B by C. So that becomes A by C times C by B. A by B. This is what we saw here. So this relationship also holds true. Yeah. Now, there is one more thing that we talked about in the previous class, and that is unit circle. And my question to you all was that why do we even need to bother about unit circle when we know trig functions already? Yeah.
Because using the trig functions and your normal triangle, you can only go up till 90 or 0. But
Yeah.
the unit circle, you can go above for like 360 or more.
Yeah. So in the unit circle we learned, as Pranit said, that when you're dealing with trig functions, keeping the right angle triangle in mind, you can only go up to 90 degree. If you have to go beyond 90 degree, the right triangle doesn't support that. This is the maximum angle 90 degree. You cannot have another angle which is 90 degree or more, because none of the triangles ever in our lifetime will have sum of all the angles being more than 180 degree. So unit circle, let me not go to unit circle because I'll be mixing two things, but basically what Pradeep said, I'm just repeating that unit circle helps you use the same concept in a little different way, where any point on a unit circle, the coordinates of that would be cos theta comma sin theta. And if anybody is struggling right now to figure out what I'm talking about, don't even worry about it. You can watch the video of the previous class, you'll be able to recall. Let's not change topic or switch topics to get more confused. But unit circle basically helps you deal with angles more than 90 degree. If you have a right angle triangle and then you're dealing with trig functions, you can only deal up to 90 degrees. If you have a unit circle, if you're taking unit circle as a reference, sky's the limit. You can think about sine of 1,020 degree as well. Okay, so let's keep it aside for now. We'll not try talking about unit circle. That will just add some complexity to what we are discussing. Not because that is complex, just because we want to stick to this concept for now. Is that okay? Or I'm getting you guys more confused? Everybody okay so far? No complaints with the teacher? Okay, let's move on. So this is Sokatwa. There's nothing new that we have learned so far. But I wanted this base to be firm before we jump onto something which is relating to the concept of complementary angles. Anyone in the class who recalls what is that relationship of complementary angle? How does it come into play? How does it actually help? Yeah?
It's when two angles add up to 90.
That is complementary angle. How do you apply that in
So
trig functions?
if you look at it, sine of theta would be equivalent to cos of 90 minus theta. Because if you set the other angle other than theta or the 90 would be just 90 minus theta, because if you have a 90 degree angle, the other two angles have to add up to 90 to make 180. So you'd have 90 minus theta as the other angle, and then if you do cosine of that angle, you get a over c, which is sine of theta.
Okay. So what Pranit is saying is, anybody else who wants to describe what is complementary angle concept with respect to trigonometry or trig functions? Yes, Jenna, go ahead.
Isn't it like two like special triangles or something? It's like 45 equals 90, or like 35. I forget the number.
Okay. Now
Isn't that a thing we're supposed to know?
No, you are certainly able to recall some part of it, but I'll make it more comprehensive. Anybody else? Go ahead. And kids, again, my thing is simple. What is my motivation for doing this class? I love it when I see you guys participate, argue, discuss, debate with me. That's what gives me the confidence that, okay, we are talking at the same wavelength. Obviously, though, there's a huge age difference between me and you guys. But then, when it comes to math, we all have to be like kids. And I transform into a kid when I'm teaching you guys, okay? I want you guys to argue with me, put your thoughts, give your understanding, share it with me. And in a way, when you do that, you get more confident with what you know. Okay, anybody else? Give it a try. Let it be wrong, that's fine. Kushi, do you want to give it a shot there? Okay, Ritika wants to say something. Go ahead. Kushi.
Wait, I know what like complementary angles are, but like I don't know how I know that there were two angles that are like 45 and 45 and add up to 90. But like I'm not sure like how it like relates to like the trig.
Wonderful, that's my motivation, but okay. When you guys say something, there's something that I can teach, I get excited about it. Kushi, you want to give it a try? or Dave, Vishwa, anybody? Hey, Nikhil. No, guys, don't be shy, okay? You're talking to somebody like your dad, a fatherly figure in front of you who is not even ashamed of making mistakes. You guys should be overly confident, okay? Let's look at it. So, what Praneeth was saying was this. Arush, you agree with Praneeth? You have a different point of view? No, you're fine? Okay. So, what Praneeth was saying is, let's not waste our time and let's complementary angle says sine of theta equal to cos of 90 degree minus theta. This is one of the rules. Same way you can say cos of theta will be equal to sine of 90 degree minus theta. And now you will see again, you guys have to not convince anybody else. You have to convince yourself that why in the first place we are actually bothered about finding out these things. This one says, let's agree to what Praneeth said, okay? And we'll figure out whether he is right or not. But what Praneeth is saying is, if you know sine of a theta, let's say he knows sine of 30 degree is equal to 1 by 2. He's saying that if you know sine of 30 degree, I can figure out what is the value of cos 90 degree minus 30 degree. Because cos of 90 degree, sine of theta is equal to cos of 90 degree minus theta, meaning sine of 30 degree, so this is my theta, will be equal to cos of 90 degree minus 30 degree, which is equal to 1 by 2. So what he is saying is, if I know sine of 30 degree equal to 1 by 2, cos of 60 degree will also be equal to 1 by 2. Tomorrow if somebody says cos of, and this reverse of that is also correct, cos of theta is equal to sine 90 degree minus theta. So if somebody says cos of 5 degree is equal to some value, somebody has given you some value, maybe 0.92. Okay, I'm just making it up, okay, I don't remember the value. No. Somebody says cos of 5 degree is equal to some value, find out the value of cos sine 85 degree. You will say, you are kidding me, the same. Cos of 5 degree is equal to sine of 90 minus 5, which is sine 85. So it will be the same value, 0.92. Now, this is where I'm kind of forcing you based because I believe Praneeth. Which I don't do usually. I don't believe anybody. But I'm saying as a group, let's assume what Praneeth is saying is right. So if this theorem is correct, if this rule is to be believed, then it makes our job easier. If you know sine of one value, you can find out the corresponding value of cos, which is 90 minus that angle. This will be the same. And again, these angles are complementary. See, 30 and 60 are complementary because they add up to make it 90. So two angles are called complementary if they add up to make 90. Okay. So sine, if you know something of sine, the corresponding complementary angle of cosine will be of same value. That's what this rule says. And then let's not dig into it. Is everybody okay so far, or I'm going way too fast? Sananya, Vivan, everybody with me? Samriddhi, Dave, okay, alright, yeah. So now, let's first find out a reason to believe Praneeth, okay? Again, I'm picking on Praneeth because he dared to answer this question. So that's why I'm calling out his name. And once we all agree to what Praneeth said, then it becomes a concept for all of us, not for Praneeth alone. So now let's look at it. What Praneeth told us to believe is sine of a theta is equal to cos of the complementary angle. Okay? Now let's look at this triangle alone. We are not going to go far from this Sokatua. Let's look at this. If this is theta, what will the value of this angle? Anybody except Praneeth? If this angle is theta, how much is this angle in this triangle? Tell me. Yeah, go ahead, don't be shy.
Then it is 90 minus theta.
Exactly, 90 minus theta. See, all these angles will add up to make it 180. This is 90 already, so these two angles will add up to 90. If this is theta, this has to be 90 minus theta, correct? Do you guys believe me or you don't? I mean, do you agree to what I'm saying right now? In this right angle triangle, this angle is 90 degree. I just print this angle as theta. Just a variable. If this is theta, what will be this angle? 90 degree minus theta. Jana, Vivan, Kritika, do you guys agree or you don't? This is pin drop silence, and that shakes my confidence. Can everybody hear me okay? Can everybody see the board okay? Okay, so I'm repeating. I was asking beta that this is a right angle triangle, okay, that you see on the board. This angle is 90 degree, okay, and this angle I'm saying is theta. Yeah. What is the value of this angle? It will be 90 minus theta, right? Because these two angles will add up to 90 degree. That is how sum of all the three angles is 180. Yeah?
So?
Yeah, yes, Peter, go ahead.
I don't know.
No, you guys are overthinking. See, this, okay, first thing, let's go back to basics. Keep our life as simple as possible. Sum of all the angles of a triangle is how much? 180. No denying that. Yeah? Okay. So this angle is 90 degree. So this angle plus this angle plus the third angle. Let's say this is x. Okay? Will be equal to how much? 180 degree. This angle I am saying x. Okay? I am not saying 90 minus theta. Okay? So 90 plus this theta plus this angle which I am saying is x is equal to 180 degree. That means x will be equal to, I am just keeping x on this side, everything else travels cross the equal to sign. So it will be 180 degree minus, this becomes minus 90 degree minus this theta. Yeah? Now 180 minus 90 would give you 90 and then you have a minus theta. This is what I was saying. Now is it worth believing? Kushi, Vishal, everybody, Dave? Yeah, Jana? Yeah, Jana, go ahead.
Wait, what is that, like that zero looking? Like, what is that?
It's theta. So this angle is theta, okay? I'm like, you have variables x, y, z. I'm saying this angle is theta. So this angle is 90 degree, this angle is theta. Theta, which looks like a zero, but with the line cutting it to half, kind of. Yeah?
Wait, so does it have any value or no? Is it just like...
It's just a variable, right? Like you have equations you deal with x, y, right? So I'm saying this angle is theta. It could be 20, it could be 70, it could be 90. Well, that we'll figure out. Yeah?
Okay.
So this is 90, this is theta. I'm saying this one will be 90 minus theta. Is that acceptable so far? Yeah? Everybody? Okay. So now, we have the same triangle, same right angle triangle. This is theta, and from the SOHCAHTOA we thought, okay, sine of theta will be opposite side divided by hypotenuse a by c. Cos of theta will be adjacent side, that is b over c. And tan of theta would be opposite side divided by adjacent side, a over b. Now, we are bringing a little bit of change in our life. Now, let's look at what is, if I take this as an angle and then apply SOHCAHTOA. So let's say sine of 90 degree minus theta. This angle is 90 degree minus theta. This is theta. These two add up to make it 90 degree. That's how they are called complementary angles. Correct? So this is 90 degree minus theta. So sine of this theta, sine of this angle, which is 90 degree minus theta, will be equal to what? Side opposite to that is b, divided by hypotenuse. And this sine of 90 degree minus theta equal to, this is the angle 90 degree minus theta, side b divided by c. Apparently what you see is this b over c is nothing but your cos theta. Yeah? I took this angle, found out sine, cos and tan, applying SOHCAHTOA. Okay? Now I am taking this angle and applying SOHCAHTOA. So sine of this angle will be side opposite to that by hypotenuse, which is b over c. And if you compare this b over c, It is matching with cos of theta. So sine 90 degree minus theta is equal to cos of theta. Done deal. First theorem that Pradit was saying holds water. We can believe it. Same way, cos of 90 degree minus theta will be, again this is my angle, cos of this angle. So side adjacent to this, that will be A over hypotenuse, A over C. And if you compare that with this guy, which is equal to sine of theta. So what you are seeing is sine of 90 degree minus theta equal to cos theta, cos of 90 degree minus theta is equal to sine theta. This is what the rule of complementary angles say in terms of trigonometry. It says that sine of an angle is equal to cos of the complementary angle and vice versa. Sine of an angle is equal to cos of the complementary angle. An angle which complements it, meaning an angle that adds up to make it 90 degree. Cos of an angle is equal to sine of the complementary angle. That's the second rule. Is it okay now, everybody? Kushi, Ivan, Ritika, Samriddhi, everybody? Saranya, Nikhil? Okay. Anybody who wants to spend 2 more minutes with this, or we are good to do rock and roll with this, whatever we've learned so far? Let's move on. Now, let's look at, see, all these are theory, all these are concepts that we need to understand. But then, actual fun is when you apply them for solving real problems. So, only thing that you have to take away from what we have discussed so far is, obviously, Sukrat law that you guys know by now, the trig functions. And then, the rule of the complementary angles. And let's see that if that is good enough to deal with some problems relating to that. So let's look at some problems. And there is one more concept that is about similarity of triangles that we talked about in the previous class, that if you have two triangles, similar meaning they have matching angles and their sides within the same ratio. So the problem that we'll deal with today, that will relate to either trig functions or similarity of triangles or the complementary angle concepts. Let's look at some of the problems real quick. There is a right angle triangle M N L, and there is another right angle triangle P Q R. It says in the figure, triangle LMN and PQR are similar triangles. They are similar triangles. If tan of P, when you hear a question like this, tan of P, so basically I am talking about this triangle. Tan of P, meaning the angle that is made at point P, is equal to 5 over 12. What is the value of tan of L? What is the value of tan of L? Meaning the angle that is formed at point L. So again I am repeating the question. It says there are two right angle triangles LMN and PQR. LMN and PQR are similar triangles. They are similar triangles. If tan of P, tan of this angle is equal to 5 over 12, what is the value of tan of L? And you are given 4 options: 5 over 6, 5 over 12, 5 over 13, 5 over 16. Yeah. Okay. Arush? Which one?
B, right?
Okay. So, okay. Everybody else here. Did you guys hear the question? You have two right angle triangles and they are also similar. And it says tan of this angle is equal to 5 over 12. We have been asked to find out what is the tan of L, this angle. And there are 4 options given: 5 by 6, 5 by 12, 5 by 13, 5 by 16. Any idea? Everybody heard the question, right? Okay. You guys have 30 seconds to solve it. Yes, Ritika.
I got B.
I'm
5 over 12.
I'm sorry, beta?
I think it's B.
You think it's B?
5 over 12.
Okay, how about Jenna?
I got B too.
You also got B. Anybody else who wants to give it a try? Disagree with Ritika and Jenna or agree with them? Yeah, Vishal.
I think it's B.
You think it's B. Nikhil?
I also think it's B.
Saranya?
I got B.
Dev?
I got
Same B. Vivan? Kushi? Yasmita?
I got B.
You also got B. Okay. So I'll not take much of your time. This is straightforward, okay? See here, okay, the only thing that we have to keep in mind is when it says that these two triangles are similar. Similar meaning their sides are in the same ratio. Meaning if you're talking about this similar meaning, this angle and this angle will be same, this angle are same, this angle are same. If the angles are same, their sides will be the same ratio. So side this to this will be equal to this to this. Or this by this will be equal to this by this. So or this by this will be equal to this by this. So basically your sides are in the same ratio. Okay? If you still want to plot it here, okay? Now ln this side will be by PQ will be equal to mn divided by QR will be equal to ln divided by PR. Okay. Now look at this one. If you are talking about angle P is what? So if you are talking about 10 of this angle, that will be this by this. So QR by PR. Let's look at what is QR by PR. So QR by PR. So we'll take this combination. So Mn by Ln will be equal to QR by PR. By PR. And this is nothing but 10 of P. This part. QR by PR is 10 of this P. Now, same thing, 10 of P is equal to Mn by Ln. Mn by Ln, which is what? This angle is 10. Yeah? So, one way to look at it would be, okay, they are the same, they are similar, so their sides are in the same ratio. If I take a layman's approach, say, okay, these two triangles are similar, so their sides are in the same proportion. We put this thing here. Now, from this one, we say, okay, fine, 10 of P will be this by this. From this one, we'll pick up the combination that gives me this by this. So, these two combination will give me that. So, QR goes here, Ln goes here. So, Mn by Ln will be equal to QR by PR. QR by PR is nothing but 10 of this angle. And it is equal to Mn by Ln. Now, Mn by Ln is nothing but 10 of this angle, which is anyway same. So, you can either make the judgment based on the similarity concept, or you will say, okay, if the triangles are similar, their sides will be in the same ratio. You can straight away say that, okay, 10 of this will be equal to this, 10 of this, 10 of this will be equal to 10 of this, 10 of this will be equal to 10 of this. Or even sine or cosine for that matter. Yeah. Did I say it okay, or I got you guys more worried? Everybody okay? Yeah, Jana.
For similar triangles, do they also have the same angles?
So they have to have matching angles. So if you are saying triangle A and triangle B are similar, I am saying one angle of triangle A is equal to one angle of triangle B. Angle 2 of triangle A is equal to angle 2 of triangle B. Angle 3 of triangle A will be equal to third angle of triangle B. Yeah. So they might not be same among themselves, but for every angle there will be a corresponding matching angle between the two triangles. Yeah? Everybody clear? Let's jump on to the next problem. Everybody okay so far, right? Dev, Vishal, you guys okay? Sahid okay? Sahid is feeling very lonely because Davik is not there. Sahid and Davik, when they are in the class together, they have a lot of things to exchange and share. Since Davik is not in the class today, he is feeling very lonely. Is it Sahid? Yeah, see? Okay, let's go to the next problem. Okay, in a triangle ABC, the measure of angle A is 90 degrees. So there is a triangle ABC. Measure of angle A is equal to 90 degrees. AB equals 10. BC equals 16. Okay. Then there is a triangle DEF is similar to this ABC. So there is a triangle ABC where angle A is equal to 90 degree, AB is equal to 10, BC equal to 16. And I mean, if you want to figure it out, this is A, this is B, and this is C. It says angle A is 90 degree, AB equal to 10, this is 10, and BC equal to 16. So BC equal to 16. Okay. Now it says there is a corresponding, there is a triangle similar to ABC, which is called DEF, where DE and F corresponds to A, B, and C. So DE and F corresponds to D, E, and F corresponds to this one. So basically it's saying that okay, if you are saying this triangle is similar, D corresponds to A, E corresponds to B, and F corresponds to C. That's what it meant by saying DEF corresponds to A, B, and C. Okay. So now there is no question about which angle is matching with which angle. Okay. And each side of triangle DEF is 2 times the length of the corresponding side of triangle ABC. Each side of DEF is 2 times of triangle ABC. We have been asked to find out what is the value of sine of F. Sine of F. That's what we have to find out. So let me read the question one last time and I'll let you guys break your head with this. It says in a triangle ABC, the measure of angle A is 90 degree. AB is 10, BC is 16. Triangle DEF is similar to ABC, where vertices D, E, and F corresponds to A, B, and C respectively. And each side of triangle DEF is 2 times the side of the corresponding 2 times the length of the corresponding side of ABC. What is the value of sine of F? So you have to find out the value of sine of F. Yep. Say again.
5 by 8.
Okay. Everybody heard the question? Yasmita, Saranya, Ritika, Kushi, Dev, everybody? Vishal? Go for it. I'll take a quick fat nap for 5 minutes, then we'll talk to you. Not 5 minutes, okay? We have 3 minutes. Yes, Jana?
The answer should be 5/8.
Okay. I'm not saying yes or no for that, but I'll give everybody another 2 minutes and then we'll see. Yes, Vishal?
Does it have been reduced? Like the fraction?
It doesn't say so in the question. The question only says that these 2 triangles are similar and DEF vertices are corresponding to A, B, and C. And it says each side of DEF is 2 times the corresponding side of ABC.
I got 5/8.
Okay. We'll see. And that is sine of F, right?
Yeah.
Okay. Yasmita, Nikhil, Vishwa, Ivan, go for it. What happened, Samriddhi? Very quiet, beta. Tired of the teacher already?
Oh no, nothing.
Okay.
I was just.
Okay. No, I mean, I'm just making sure that everybody is with me. And I'll keep on reminding you guys that I'm not letting anybody take a nap except me. Okay. You also got the same value? Okay. I'll just give you guys one more minute and then I'll quickly check this and then we'll move on to the next problem, which might be more interesting than this one. Kushi, how is it going?
Good.
I'm sorry, beta?
What did you say?
No, I was saying, how is it going? How close or far are you to getting a solution for this one?
I'm trying to do it still.
Okay. Yeah, Dave.
Wait, it says that, wait, I can't see what the thing in the back says. A double?
Which one? 2 times.
Okay.
So it says that, first of all, it says this triangle are similar, and DEF corresponds to ABC, and then each side of DEF is 2 times of the corresponding side of ABC. So we have to find out sine of F, this one.
Oh, okay.
Yes, Mita, what's happening, Mita?
I'm still doing it.
Oh, okay. I'll give you guys maybe 1 or 2 more minutes. And then I will start with my simple approach. Yes, Dave.
What if it's 10 over 8?
Say that again.
What if it's 10 over 8?
10 over 8?
Yeah.
Okay, we'll see. We'll anyways check. But one thing, okay, without me validating it, we are trying to find out sine of f, and sine value varies between -1 and 1. 10 over 8 would be more than 1. So that will be a red flag for me, even without any review. Just review once more there, okay?
Okay.
Yeah, Vivan,
Sir, I got 10 over 16.
10 over 16, okay, which is same as 5 over 8, right? So your answer is also matching with the answers we have got. Yes, Saranya?
I got 5 over 8.
Okay, so far everybody is on the same page. I'm pretty sure Dave probably missed 2 of it.
Wait, I'm confused. I got 5 over 8 and I doubled it because it says it's 2 times the value
So
of the triangle.
So then you have to multiply it by 2 on numerator and denominator both, right?
Oh, I only did numerator.
Yeah, because it says every side is 2 times. Every side of DEF is 2 times the side of corresponding side of ABC, right? So, yeah. I mean, I knew where you might have gone wrong. Your approach was fine. Probably just one calculation miss. Yep. Okay. So let me do it in the simplest way that I understand, right? I'm pretty sure you guys would be doing it the same way, but I'm just trying to oversimplify this with my approach, right? So this is given as 10 and this is given as 16. Now, here, these 2 triangles are similar, okay? We just saw in the previous problem also. D, E and F corresponds to A, B and C. That's what it is told, okay? Now, it says every side, second point was that every side in this triangle is 2 times the corresponding side in ABC. So if this is 10, this is 20. If this is 16, this is 32. This one is not known, this one is also not known. So if this is x, this is 2x. Let that be the understanding. Now it says find out sine of f. Sine of this angle f. Fine. Sine of any angle f will be equal to the side SOHCAHTOA. So, yep. Sine of any angle will be opposite side divided by hypotenuse. What is my opposite side? 20 by hypotenuse 32, which is 20 is 5 times 4, 84, 32 is 8 times 4, tic-tac-toe, 5 over 8. Yep. Is this okay or I'm getting everybody confused? Very simple, right? So basically now if you look at it, right, most of the things that we do, it's all about we being very clear about the concept. As long as we have no doubt about SOHCAHTOA, as long as we clearly understand what similarity means, no big deal. Yep. Let's look at some more problems. And word problems always have the intention of getting us confused. It is in our own interest to keep that confusion as much away as we can. Yep. Everybody okay, right? Everybody was convinced about whatever solution I was showing? Yasmita, Khushi, Nikhil. Yeah? Okay. Vishal, alright. Let's move on to the next problem. So, let's go to the next one. Okay. I have another question, and unfortunately all these questions are testing my drawing skills, which is horribly bad, but I'm still managing to survive. Okay, this is, see, I'm not able to join the edges. Okay, so there is a triangle E, F and G. This is given as 7 root 6 and this is also given as 7 root 6. It says what is the measure of the degree of angle EFG? EFG. What is the measure in degree of angle EFG? So EFG. We have to find out this angle. Everybody heard the question? Everybody saw my wonderful drawing? Okay. So this is the triangle EFG. This side is given as 7 root 6 and this side is also given as 7 root 6. We have been asked to find out the measure of angle EFG from this information. Yep. How much? And you guys, whoever is stressing out right now, will probably have a big smile on their faces once you get the solution for this. Just think about it. Problems are not difficult. And there is one more information that I missed. Okay, let me give you guys a clue here. Do you know what this sign means? Yeah? Yeah, what is that?
Isn't the triangle of 45, 45, 90 triangle?
Yeah, it is. Yeah, Vishal. This one means 90 degree, okay? Whenever you see this symbol, right? Without any description for it.
What's the question asking?
I got for F, I got 45 degrees.
45 degrees, yeah. We have to just find out this angle in degrees. EFG. So EFG, the way you read it is EFG. Whatever in the middle, that is the vertex that we are talking about. Yep. So this was a very easy question if you look at it. This simply says, just by looking at the picture, it says this is 90 degree. Whenever you see a sign like this means 90 degree, okay? So this angle is already given as 90 degree. And say these two sides are same. So this is right isosceles triangle. Meaning these two sides are same and this is 90 degree. That means this angle and this angle have to be same. And sum of these two angles is 90 degree. When these two are same, so one of it would be 90 by 2, which is 45 degrees, simple. Just by looking at the picture, you should be able to derive it. It is a, if you get a question like this in your exam, it's going to be something that should be solved in 15 seconds. That's it. It is your scoring question actually, if you look at it that way. Yeah. So maximum effort will go for reading it, and then as soon as you see this thing, these two sides are same, and this is 90 degrees. So this is right isosceles triangle, meaning these two sides are same, angles are same. Yes, Jana?
What would be an example of like a 30-60 triangle?
That will be based on, I mean, once you get, so an example would be like this. Let's say this is 30. Okay, I'm just trying to derive the value. Okay, this will be 5 and this will be 10. No, this will be 10. Something like this. Basically, when your sine of, so sine 30 as we saw in the previous class, right, is 1 by 2. When a side and the hypotenuse ratio is half, side by the hypotenuse is half, that is your 30 degree, other angle will be 60 by default. Yeah? Does it make sense, Jana? Everybody? Okay. But is everybody clear about this particular question? This was a simple one, but sometimes, I mean, all the questions are simple only as long as we understand the concept, right? But is everybody okay? Yes, Mita, Kushi, Vivan, Saranya, everybody okay? Okay. Let's move on to the next problem. This one will be interesting, little interesting. Okay? It's not interesting because it is tricky. It's interesting because it's testing my drawing skills. This is rear chain and this is front chain. Okay. Now it says a restaurant saves space by installing an overhead glasses rack. The rack will tilt upward by x degree. This is x degree. Okay. So this is upward tilted glasses rack. Okay. This is tilt upward by x degree. So basically this would have been flat, but this is tilted by x degree, as shown in the figure. So the glasses do not slide out accidentally. The front chain is 4 centimeters shorter than the rear chain. So this chain is some length which is shorter by 4 centimeters than the rear chain. What must be true about the angle x? So basically, here it says this length is 46, this length is 4 centimeters. You have been asked to find out what is the value of sine of what is the value of x, what is the degree of x. So the question is, a glasses rack is installed where the rear chain is 4 centimeters taller than the front chain. This is the front chain, this is the rear chain. And this says this length is 46 centimeters. And this is tilted such that it is making x degree with the horizontal axis. So we have been asked to find out what is the value of x, and you are given 4 options. What is true about the angle x? Sine of x degree equal to 4 by 46. Sine of x degree equal to 46 by 4. Sine of 10 of x degree equal to 4 by 46. 10 of x degree equal to 46 by 4. Which option you choose? A, B, C, D. Yep. Okay. Okay. Anybody else on the screen? You guys have 2 minutes to get me the answer for this one. It says that, see, this is a picture, okay? I mean, where this is the rear chain, this is the front chain, and they are adjusted such that the front chain is 4 centimeters shorter than the rear chain, meaning this distance from here to here is 4 centimeters. And this distance is given as 40. The length of the chain is given as 46 centimeters. So we have been asked to find out which is true about the about the angle x. Yes, Vivan.
Sir, I have a question.
Uh-huh.
How do we know what is opposite and what is adjacent?
You always take the angle into consideration. Opposite or adjacent trigonometry hereafter is all about which angle you are talking about, and the side opposite to that will be this. Adjacent to this angle will be this. If you are looking at this angle, then side opposite to that will be this, adjacent will be this. Yeah? Jenna?
I got A.
Okay. Everybody sit down without making noise. Your class has not started yet. Anybody else? Yasmita, Dev, Vishal, Khushi, Sharanya. Yep. Yeah, Vishal.
We're saying which one's true, right?
Yep.
A is true.
Yeah. So I'll just quickly rush through this. Okay. So this is what is given. This is the rear chain, which is 4 centimeters taller than the front chain. So this is the front chain, meaning from here to here this distance is 4. I'd say that it is installed such that it's tilting at angle x to avoid it falling. And all that is story. What it translates into this picture is this length is 46, this length is 4 centimeters, and this is a right angle triangle for us. If this is the angle, side upward to that is 4. So sine of x degree will be equal to opposite side by hypotenuse, which is 4 by 46. Anyways, whenever you look at things like this, rule out, this is not an option at all. This is a straightforward answer in this way, so you don't have to worry about it. Yeah. So with that being said, I will let you guys go. You guys dealt with enough of my drawing skills and we learned something. But we will deal with more problems, more different topic in the coming class. Anybody have any questions, please reach out to me on WhatsApp. So send those questions, don't hesitate, don't be shy. Alright? I will let you guys go, enjoy the rest of your evening.